All right, kiddos. Hopefully this assignment is way shorter than the one before. The last one was a beast. Um, this one is about linear approximation, and the idea behind this is this. Um, Linear approximation. So what we're going to be given is we're going to be given some graph of f of x. We're going to be given some equation f of x. Now, sometimes it's really easy to use f of x, but sometimes it's not very easy to use. So let's say I want to know what is the f of x at that point right there. But let's say that that's a really difficult calculation to obtain. It's really hard to get that. So this is the idea of linear approximation. What we're going to do is we are going to take the derivative and find the equation of a tangent line somewhat close to the spot that we want. Okay, so we find this equation of a tangent line. And then what we do is then we plug in the value that you want. All right, so this is kind of hard to explain. So I'll give you a quick demonstration on how this can be used and what this can be done, how we can use this and what good it does. All right, so let's take a look. Let's think of the square root of x. Okay, the square root of x. And I want to know what the heck is the square root of 102. I want to know what is the square root of 102. All right, so we have the square root function. And I want to know what is the square root of 102. Now, I don't know. I don't know off the top of my head. So what we're going to do is we are going to take a tangent line substantially close, and we're going to use our tangent line as an approximation. And so what I'm going to do is I am going to approximate a tangent point at when x is 100. When x is 100, I'm going to take my tangent line and I'm going to use that as my approximation for 102. All right, so here's how the process works. So we know the point of tangency is 110, okay? But we need to know the slope of our tangent line. So if f of x is square root x, what is the derivative of that? And that's going to be 1/2 x negative 1/2, aka 2 square root x on bottom. All right, so that's all tangents, and now I want my tangent specifically when x is equal to 100. I want to know what is my tangent when x is 100. So that's what, 1/20. Okay, 1/20. So completing this out, doing the finding the equation of my tangent line, where I go what y minus y1 is equal to m x minus x1. This is going to be my quote unquote linear approximation. That'd be y minus 10. Again, I'm using my tangent line, so this is the tangent line, is equal to m x minus x1. All right, so this is my linear approximation right here. Now, again, the ultimate goal is, what the heck is the square root of 102? So what I'm going to do is I am going to use this as my approximation. So this would be 102 divided by 20 plus 5. My linear approximation says that this should be equal to 10.1. Right? 10.1 is my linear approximation. Usually I give it as a fraction. Now, is that the actual answer? No, that's not the actual answer, but you would be amazed at actually how close it is. You'd be amazed at how close it actually is. And so what we're doing is we're not actually taking the point, but we're rather taking a point on the tangent line as the linear approximation. Okay. Okay, so find the tangent line approximation t. Okay, so that's our linear approximation, and we're going at the point 2,4. All right, so we need to find the slope of our tangent line. So our slope of our tangent line, 2x, but they specifically want it when x is equal to 2, and so that's going to be equal to 4. So the equation of our line is y minus y1 is equal to m x minus x1. So our linear approximation is 4x minus 4. Okay, that's our linear approximation of this. So this is that t formula. All right, so they want to know what are actual squares. So 1.9, excuse me, as you were, 1.9 squared. So these are the actuals. All right, and then our linear approximation model. So that is 4x minus 4. So really close. Wow, that's really close. If I wanted to know what is the value when x is equal to 1.9, man, my linear approximation is really close. Yeah, linear approximation is crazy close to what these actual answers are. So if you wanted to know, hey, what is 1.99 squared? Instead of actually doing the mathematics of it, what you can do is you can just take 1.99 and plug it into, a lot of times, an easier formula. And that's the idea behind the linear approximation. Okay, so same idea. Let's change colors here. So we need to find the slope of our tangent. We're taking at point 2. So that's our slope. So our equation is y minus y1 is equal to m x minus x1. So the actual is x to the fifth. So I'm going to go 1.9 store x to the fifth is 7610. Yeah, that's one, man. Give me one second. Okay. Pretty close. It's a pretty close approximation. Again, really close. Should be spot on. Oh, shoot, I accidentally did the last one. So our approximations are really close to what they should be, the actual answer. So again, this won't give you an exact answer to these difficult questions, but the answer that you do get from this line is pretty close to the real deal. All right, sine x. All right, so that's my linear approximation. I don't know what that is. Okay. So let's go with 1.9. So the original sine of 1.9 is 0.9463. now I am going to check out x cosine 2 minus 2 cosine 2 plus sine 2. 1/100th off, not even a half of 100. Let's make our x 1.99. How close that one is. Crazy close. This should be the exact same thing. Again, crazy close. Okay, so they just want us to, in essence, verify that and graph both of them on the same viewing window. Okay, so f of x as it stands is x plus 4 1/2. So the derivative and then times 1 with the chain rule. So this is 2 square root of x plus 4 underneath 1. They want to approximate at point 0. So this is 0 plus 4, which is what, 2, 4, 1/4. Thus, the approximation would be y minus y1 is equal to m x minus x1. And that is the linear approximation. And that is what they provide. Now they want you to graph both of them on the same viewing window. So I go to my calculator here and I put in the square root of x plus 4. And again, it doesn't really matter which one you use. 1/4 x plus 2, which is the same difference as saying 2 plus x plus 4, or x divided by 4. So we'll assume 6. So there's that. And then the point of tangency should be at 0, 2. Point of tangency should be at 0, 2. There you go. That's it. Okay. Linear approximation, it will be used. It will be used and it will be on the AP test. Linear approximation. So again, what you do, the idea behind it is if you get this impossibly difficult question, what you do is you make a line that is somewhat close to this 102. Like, I don't know what the square root of 102 is, but I do know what the square root of 100 is. And so what I do is I take something substantially close to this 102, and I use this line that is produced, this tangent line, as my approximation, because this line equation is way easier to use than figuring out what the heck the square root of 102 is. It's really hard to find a square root of something that you don't know. All right. So what you do is you take this line, and I can plug and chug 102 in here, and I can get that with paper and pencil if I really needed to.